Lithoz. Lithoz is a bioceramic company. Specifically, they manufacture 3D printers capable of printing different types of ceramics. Specifically, again, HiMed, we're interested in hydroxyapatite and tricalcium phosphate. And the goal of this partnership is being able to use our materials to ultimately create bioinks, which are more consistent as far as how the material performs. And ultimately, we can hopefully produce different complex shapes, different porosities, different functions for many orthopedic applications. So again, this is a pretty new technology. I have to admit, last week I attended Additive Manufacturing Strategies. It was a really popular event in New York, and everyone's talking about metal 3D printing and polymeric 3D printing. And the number of people that came back to me and said, wait, you could do that? Right? And this is a show that's dedicated just to additive manufacturing. So I do recognize that this is a newer technology. As the name Lithoz suggests, it's a lithography-based 3D printing mechanism. So there's 4 steps to simplify the process. One would design a CAD file of the device that you're looking to print, and then ultimately a rendering of that image is cast through the software that we have, and we're able to print layer by layer. There's a projector system in the bottom portion of this printer, and ultimately based on the way that that image portrays, one can take the device and be able to print consecutive layers, and over a number of different iterations, we can print. I realize I'm covering the final product in the upper right-hand corner of the screen, but this, of course, would be an orthopedic screw that was 3D printed, in this case with hydroxyapatite. But one might be interested in printing with a biphasic calcium phosphate, where perhaps there's a gradient along the screw depending on where the more stable hydroxyapatite would be desired, as opposed to a tricalcium phosphate, which is going to be more resorbable. So there's a lot of interesting technology that could come about from this. In fact, Lithoz, they just released a dual-headed printer, and you have the ability to print with multiple materials. Currently, when I describe biphasic calcium phosphate, say 70-30%, I'm talking about, say, taking 70% HA, 30% of beta TCP, mix them up, and then you have one homogeneous solution. But now the idea of being able to have 2 separate vats with 2 printer heads, and to more clearly define what everyone is looking at, this is the print stage, and it dips inside of this vat. This vat has a slurry, and this cylindrical column is where the ink would be dispensed from. So again, HiMed, I certainly am learning the technology as everyone else is, but where HiMed and specifically our team is introduced to this process, it's being able to create inks that perform consistently from batch to batch. The concern for many folks that are highly invested in this type of technology is that they might be able to print 1 screw, but how do you print hundreds of screws, thousands of screws, right? And for that matter, before we could print hundreds of screws, we're printing 1 screw initially. And I think that's where the AI comes in, as far as being able to be more predictive for types of forms, if it's a porous form, if it's a solid form, what types of structures or perhaps platform stages might be needed in order to ensure that the material is properly adhered to the build plate.